All right, we're now in Chapter 9, Section 1. Here's problem number 13. As you can see, in order to investigate the relationship between the mean job tenure in years among workers who have a bachelor's degree or higher and those who do not, random samples of each type of worker were taken with the following results. You see that they give us this two different samples, the sample size, the mean of those samples, and the sample standard deviation. And you can see that one of the things that quickly comes to the thing that I look at is the sample size. These are both larger samples, both greater than 30, so that's good. You need to think about, are these independent as well? That these are two different groups of people and they're randomly sampled, so we can be assured that they're independent. So 3 things for us to do. First is A, construct the 99% confidence interval for the difference in the population means based on these data. Let's go ahead and do that. So on A, we're doing the 99% confidence interval, which means our alpha level is 0.01. And this is going to be on the difference of the means. So we're going to be looking at mu1 minus mu2, that difference. Okay, so for doing this, we need to go and look at our information from this section in terms of how we calculate the confidence interval. And we're given the equation for that, which is the x1 bar minus x2 bar, so the difference in the sample averages or sample means, plus or minus our standard normal distribution variable z at alpha over 2 times the square root of the standard deviation squared over the number in the sample of our first sample, plus the standard deviation squared of our second sample over the number in that second sample. So we can actually put these numbers in at this point from what we have here. I'm going to use the first row as the 1 and the second row as the 2. And so we'll go then with our mean. We have 5.2 of the mean from the first sample minus 5.0 is the mean from the second sample, plus or minus z at alpha 0.01 over 2, so 0.01 divided by 2 is 0.005 times the square root of our standard deviation squared divided by the samples, the number of observations in that sample, 155, plus the same for the second one, 1.5 squared over 210. All right, so a couple of things. We have to get one more piece of information here, then do some math, the calculator math. So we've got z 0.05, so let me go here, so this is 0.2 plus or minus z at 0.005. We can get this a couple of different ways. We can go into the cumulative standard normal table. Inside the table, look for the 0.05005 percentage in the table to find what the z value on the outside of that table is for this, or we can go to the t-distribution and look at the t-distribution at 0.005 at infinite numbers of the sample size, where the t-distribution is equivalent to the standard normal distribution. That's where I went and got this. So z at 0.005 is 2.576. And what I'm doing here is I actually do these calculations in stages so that if I mess up or things look kind of squirrely, I can go back and find out what I did. So this is stuff I did off on the side, so it's easy for me now just to pull these off my side sheet of paper where I did the calculations. So I'm ending up here with 0.2 plus or minus 2.576 times, set that square root, 0.147. So with that, this one is it being 0.2 plus or minus 379. So my confidence interval is minus 0.179, comma 0.579. Whoop, there's a point in there. So that's my interval. Now, as I look at this real quickly, I see that that interval includes 0. So that the difference that from at my 99% confidence interval means to be 99% confidence interval has to go from a minus to a positive, meaning that the difference is to be confident includes 0. So that gives me the indication that these aren't going to be that different. Let's continue on. Let's look at B. So in B, we're doing test at the 1% level of significance the claim that the mean job tenure among those with higher education is greater than those without, against the default that there is no difference in the means. Okay, so we're looking here at the difference between our mu1 and mu2. So in this case, is there a difference or not? So we're looking at, is it equal to 0 or is it not? So this will end up being our null hypothesis here, that it's 0. So in this case, the D naught or D0 is going to be that 0. An alternative hypothesis is going to be that the difference between the two means is not equal to 0. Okay, so if we go back to our systematic hypothesis testing procedure, the critical value approach from back in week 9, we have those 5 steps. So here, step 1 for hypothesis testing was determining the null and alternative hypotheses. We just did that. Second step is identify the relevant test statistic and its distribution. Then compute the data, the value of that test statistic. So that's one thing I always do together. So this is kind of like a 1 here, and this 1 and 2, or 2 and 3, I kind of do together. If we look at our test statistic, in this area, since we've been just talking about this one, and we have a large sample size, we're looking at a difference in sample means. Our test statistic is Z, being the difference in those sample means. And we're going to subtract off the D naught in this case. So there'll be times we'll see where that is actually something different than 0. In this case, we're just looking to see if they are different. We're going to look at the square root again of our sample squared over our number in our first sample plus the sample standard deviation squared in our second sample and the number in that second sample. And you can see that this is going to be the same that we had up above, so we've already made that calculation. That's going to be kind of handy. Let me get rid of that. And we'll go from there to actually calculate this then. So our Z is going to equal x1 minus x2. We calculated that. Here's our x1, x2. We had that above as well, so we calculated that, which turned out to be the 0.2, or sorry, the 0.2. So we have our 0.2 minus our 0, which was our D naught in this case, divided by what I just mentioned moments ago, that thing we calculated back up in A, which is 0.147. So we have 0.2 divided by 0.147, which gives us 1.36. So our value of 1.36. Okay. So that's our second step. Our fourth step then is compute the critical value region, so the rejection region for our hypothesis test. So our critical value, since we're doing our hypothesis testing at a, back up there, let me look again, it's at a 1% level of significance, our alpha equals to 0.01. So we're going to be checking to see if our Z that we just calculated is going to be less than the Z.01. And in this case, we need to be looking at, yeah, okay, this is where we are. And let me pause there. I just paused for a minute there. That was kind of that da-dum kind of comment, because I was looking at this again and scratching my head, because my scratch my head, if you look at B, it's saying that looking at the job tenure among those with higher education is greater than those without. And I had said is different. So if you look back here in how I put the alternative hypothesis in place, I'd said not equal to. In this case, this should be, since we're looking at higher, that it's going to be greater than 0. So down here, I'm erasing where I just put less than Z, so this is going to be Z greater than Z at 0.01. So I had looked at that and said, my numbers are kind of funny, and why did I have that? And that is why I put in the different hypothesis test for the alternative. Excuse me. Okay, so z at 0.01, so our z value is 1.36, and z value is z at 0.01 equals, I'm going to put an equal sign there, get rid of that equal sign, that doesn't make sense. So we're going to compare 1.36, I keep trying to erase my equal sign, to z at z.01, and that's what I'm going to say equals. And here the value of that one is 2 point, had to look that one up in the table, 2.326. So the critical region then, we can say it that way, is 2.326 out to infinity. Our z is not greater than that one. So here we're saying in our step 5 for our hypothesis test that we do not have evidence at the, in this case, we're really the 1% level of significance that the population mean is greater for the job tenure in years for a bachelor's degree or higher or no degree. So job tenure, we do not have evidence to say those are different. All right, let's move on to C. So section C here in this problem, compute the level of significance of the test. So the level of significance, the observed level or the observed significance of the test is our p-value. So our p-value here is what's the p-value of our computed z statistic. So what's the p-value? So it's the probability that where z statistic equals that 1.36. So what value of probability equals that? So we look at the 1.36 for our z and come up with the probability that that is right off the cumulative normal table. And the p-value out of that table is 0.0869. And we could have looked at this as well if we calculated the p-value and compared that to our alpha value, that the p-value of 0.0869 is greater than 0.01, so we don't have enough information to reject. So at that level of significance, another way to look at it. All right, so there's our first problem in this chapter.